I'm Brian. I'm an SA over at ProphetStor, and I'm going to be talking about DiskProphet. And what DiskProphet does is we use machine learning AI to predict future disk failures up to 6 weeks in advance. And additionally, we can also predict performance and capacity for up to 90 days into the future, as well as give correlation for the effects of disk failure between the node, application, and cluster. And our biggest use case right now is for Ceph. So I know that a lot of you might not be very familiar with Ceph, but all you really need to know is that it's a distributed storage system that's self-healing and fault-tolerant due to redundancy, which makes it really good for big data storage. And you can kind of extrapolate this use case to all distributed clusters. So in 2016, we partnered with another big company that actually presented at Red Hat Storage Day in Seattle that wanted to do a petabyte Ceph cluster for OpenStack Cloud. And they found there was 3 major stability issues with the Ceph cluster that was sort of blocking their project. The first one was that every time a disk failed or an OSD failed, the map would change, the crush map, which would cause placement group peering and backfilling, or the cluster would rebalance to heal itself, but then this would take up cluster resources and the client would receive slower performance. The second issue was that the data distribution wasn't balanced. The cluster had no visibility of the underlying disk capacities. So if you had different capacity disks in your cluster, some disks might be at 90%, while the cluster was only at 50% full. And then the user wouldn't know until one day the OSD just couldn't be written into anymore because it was full. And then the third issue they found was that one slow disk, a single slow disk, would affect the performance of the entire cluster. And then this would just continue to drag on the performance until it was ejected because the cluster had no visibility over the health of the disks underneath. And so they proposed a solution with our DiskProphet prediction, which was much less mature at that time, but it essentially did the same thing. We could predict disk failures 6 weeks in advance. And then they drew out all this architecture stuff, but the most important thing is this graph at the bottom right. You can see that there's a normal workload here of around 400 or so IOPS. And then when they simulated a disk failure by just pulling a disk, they found that the cluster performance dropped below 200. So they dropped around 40 to 50% IOPS and persisted that way. It persisted that way for the whole duration of the test. So 800 minutes, around 12 hours or so. Versus with our disk prediction, you can see that with being able to know a disk is about to fail in advance, we can take preemptive measures. We can disable the cluster rebalancing, and then we can remove the disk and replace it within an hour and have the performance go back up to a fraction of the time, in a fraction of the time, right? And then the same company tested our prediction engine against 20,000 drives over the course of 90 days. And they found that we had an accuracy rate of 96% and a recall rate of 97%. And the recall rate is actually the more important statistic here. It's the number of correctly predicted failed disks over total number of failed disks. So out of every 100 disks that failed, we would correctly predict 97 of them. Okay. And then this just shows that we're already integrated in the Ceph community. We're called the DiskPrediction Plugin. You can just enable us through the manager daemon, and then you can just use Ceph native commands to access our prediction. And yeah, so we released with Nautilus. For older versions of Ceph, you would use this one-line installation, and you can use that with Ansible, Chef, Puppet, any kind of automation software to make it simple for mass deployment. And our biggest account right now is actually in Michigan. There's 3 universities: Wayne State, Michigan State, and University of Michigan. And what their setup is, all 3 of these campuses share a single giant Ceph cluster, and they put all their research data on the Ceph cluster. So they have to make the Ceph cluster as resilient as possible. And so what we provide is just the disk predictions and allowing them to monitor the health of their disks before they fail. Right. And I'm just going to go through a quick live demo. I'm going to switch screens here. Can you guys see my web browser?
Yes.
Okay. So what we have is just a simple software as a service cloud login. When you go and you see a dashboard, and it just gives you a really quick overview of how many disks are being monitored, how many are good, how many are bad, are going to fail in less than 2 weeks, less than 6 weeks. And you can go to the disk health list here to get a list of every single disk that's being monitored. And then you have all the UI unique identifiers and which node it's on, the size, the serial number, the vendor, all over here. Oh, sorry. All over here, so you can see that, so you can easily identify the disk. So, yeah, so this would be where you would go for the disk details. And then we also, I alluded to it earlier, we also have prediction for capacity and performance. So over here, we have the cluster capacity, but we also go down to the OSD level. I'll just use pools because it's more interesting. And then we can predict future capacity for the next 90 days. But of course, this depends on how much data you have. So the general rule of thumb is for every cycle that we predict, we need 3 cycles of that data. So if we can predict 10 days into the future, we would need 30 days of data. Right. And yeah, that's about all we do. That's the end of my thing. I just have some screenshots.
Awesome.
Thank you.
This is great. The other thing, can you maybe jump over to where that Ceph plugin is for disk protection, so that we have the URL in front of us while we're.
Oh, yeah. I can just go into it in my disk prediction.
I didn't realize that it was a plugin already to Ceph. So yeah, that Ceph is near and dear to our.
We work with Sage, the creator of Ceph, and he got us in there pretty quick, so pretty good.
Great to know, as we've got a lot of Ceph folks using Ceph and here at Red Hat and elsewhere. So,
Yeah.
All right.
So one interesting thing to note here is that you can run the prediction in the cloud or local. So you could also run this setup in a completely non-software as a service environment as well.
Yeah, because in order to be with Ceph, they wanted like a lightweight version of our predictor, and then so we just gave them like one with less baggage that would be only 70% accurate, that they could enable locally, but it wouldn't use all the metrics that were provided for the prediction. It was requested by them to have a local lightweight package.
Okay.
Yeah.